Hello and welcome to this video about identifying the conic section from an equation. So if we have the equation x squared minus 6x plus 12y plus 33 equals 0, and we need to identify what kind of conic section is it, we first need to complete the square. So we have x squared minus 6x, and since I don't see y squared, I'm gonna move everything to the other side, and it looks like it's gonna be a parabola because only x is squared. We'll see. So now we complete the square, so we get x squared minus 6x equal negative 12y minus 33, and now half of 6 is 3, so we must add 3 squared to complete the square, and so we add 3 squared on the other side as well. And this way we have x minus 3 quantity square is equal minus 12y minus 33 plus 9 is negative 24. And now what we're gonna do is factor out negative 12. We get y plus 2. And so this is similar to the equation of a parabola where we have x minus h quantity square equal 4p y minus k. So the vertex usually is hk, and in our case would be 3 minus 2, and since 4p is equal to negative 12, tells me that p is equal to negative 3, and the absolute value of p is 3. So let's first plot this point, the vertex, which is 3 minus 2. So I have the vertex right here, and now because I have a negative here, I know this and it's x squared, so it's going to open either up or down, and a negative makes it goes down. And since p, absolute value of p is 3, that means the distance from the vertex to the directrix is 3 units. From the vertex to the line, which is the directrix, is 3 units. So I have y equal, and this line here is positive 1. So y equal 1 is the directrix, and the focus is 3 units from the vertex as well. And so it is minus 2 here, minus 3, minus 4, this is minus 5. So in this case the focus is 3 for the x, minus 5 for the y. So 3 minus 5 is the focus. So the parabola is this up and down this way, and what we need is the focal diameter, which is basically 4p, and in our case is 12. So what does it mean? From this focus I need 6 units to the right and 6 units to the left, and connect this point, and this is how the parabola looks like. And so this is the equation of this. We have the equation of the parabola here, and this is the graph of that parabola. Let's see another example here. And so in this case we have 9y squared equal x squared minus 4. So what we're doing here is I'm gonna try to complete the square on this side. So we have 9y squared equal x squared minus 4x, and half of 4 is 2. So we square it is 2 squared. So basically I'm adding 4 here, so I'm gonna subtract 4 as well. In the same side, since I add 4 to complete the square right here, I'm subtracting 4 to make it balanced. So we have 9y squared is equal to x minus 2 quantity square minus 4. So I'm gonna move the x minus 2 quantity square to the other side, equal minus 4. And what we're gonna do, we need 1 in here, so I'm gonna divide by negative 4 everywhere, and while we dividing by -4, now I see this is going to be x minus 2 quantity square over 4, then minus 9 over 4 y square is equal to 1. Since I have a negative, I know it's going to be hyperbola. But to make it look like the form, and our form of hyperbolas is x minus h quantity square minus y minus k quantity square over a square over b square equal to 1. But we need this to go to as a denominator. So we're going to have x minus 2 quantity square over 4 minus y square over, and the reciprocal, which is 4 over 9. And here on the side I'm saying why is that? Because 1 over 4 over 9 is the same as 1 times the reciprocal, which is 9 over 4, which is 9 over 4. So I had 9 over 4 is the same as 1 over 4 over 9 equal to 1. Now I have that the center, which is in our case hk, and this center is 2, 0. So let's find the center. So x is 2, y is 0. So right here is the center of the hyperbola. And what goes, because x squared comes first, I know it's going to open toward the x-axis. So horizontal transverse. So it's going to open toward the x-axis. So under the x is 4, square root that is 2. So from the center I go 2 unit here and 2 units here, and this is the vertex v1, v2. And under the y is 4 over 9, square root that. So the square root of 4 over 9, you get plus or minus 2/3. So I go 2/3 to the top and 2/3 at the bottom from the center to make this box. So I have 2/3 here. Now all what we need to do is connect the diagonal, which makes it, now we have the asymptote for this hyperbola. Remember, x comes first, so I know it's going to open toward the x-axis. So to find the focus, we need that this is the distance a, this is b. So c, we know that c square is equal a square plus b square. So c square is equal to 4 plus 4 over 9, which is 36 plus 4 is 40 over 9. Tells me that c is 4 times 10, or 2 radical 10 over 9, plus or minus. So again, the focus will be f1, which is 2 plus c, which is 2 plus radical 10 over 3. Sorry, here this is when I square root, it should be 3, then 0, and the other point will be 2 minus 2 radical 10 over 3 comma 0. And for the line, the asymptote, so for the asymptote we have y, because we have just y here, equal plus or minus, and the slope b over a. B is 2/3 over a, and a is 2, and then multiply by x minus 2. Or to write it nicely, we have 1/3 x minus 2. And this is how we take an equation and find out what kind of conics it is. I hope this video is